welcome to my channel and welcome to my website. My name is Daryl and this is Programming in Any Language. The website is www.black-duck.com. It's where you'll find all my videos organized in logical order. You can begin with the basics and then move on to advanced concepts. You can also start with the speed track and build an application from scratch, which should pique your curiosity with a desire to learn more. What you're looking at right now is a very simple program I use in class when teaching the concept of loops. But I teach it looking at it from a problem-solving perspective. Yes, we're learning a language, but we are doing more than that. We are learning how to problem solve while using a language as a tool, in this case, C#. The program you are looking at simply has the user enter a speed at which some object is traveling, car, train, bus, whatever. The user is then prompted to enter the time, how long the object is actually traveling at this speed, 1 hour, 2 hours, 3 hours, 12 hours. The loop then calculates the distance traveled and lists how far the object has traveled with each hour. It's a nice program, and it works just fine, as long as the proper data has been entered. This is why we test. What if the user enters non-numeric characters? We need to check for that and let the user know they messed up. Of course, our program will be polite when it lets them know that. What if the user enters a negative number for speed? Going backwards? No. User entered another error. We need to check for that. What if the user enters some unreasonable speed, like 99 million miles per hour? Yeah, users just might do that. We need to check for that. What about time? Negative time? We got to check for that. 99 million hours? What about 500 hours? The user may have been 50 but hit the zero twice. It happens all the time, and we need to check for that. The actual code we write in a program is nothing compared to the code we need to write to make sure the proper data gets to the calculation portion of our program. Take a look at the flowchart behind me. On the left, before the dashed line, is the code needed to make sure proper data gets to the calculation portion of our program. The code on the right of the line will run flawlessly every time when proper data gets to this section. Take a look at how this is done. And we're writing right code. So what we're going to do is we're going to go to our calculate button. That's going to be doing all the work. So I'll jump in here. What I want to do now is I want to actually give myself a little comment here that I'm going to get input from the user. And I'm going to do that by using a try parse. But before I need this, I need to put these things in a variable someplace. So before this comment, I'm going to put, I want int speed, and that's going to hold my speed data, which the user is going to be giving us. Another one is going to call int time. And this is going to hold number of hours from the user. So then we're going to go and get our input. We do that by saying if int try parse txt speed times text out in speed. And that's going to create a bracket. So if things happen correctly here, I want to go into this process. But if it doesn't happen correctly, I'm going to set up another thing, which is going to be an else. And it's going to say message box dot show invalid speed. And give that a comment. And what we can also do at this point in time is we can say txt speed dot text is equal to space space. And txt speed focus. And this will place these are back in that spot so they don't have to go ahead and clear things. They can just put that in place. So that is an error. Now, if things went right on the text speed thing, we can go a little further on this, and we can say if int try parse txt time. And that's going to send it out to int time, and it's going to create a bracket. Now, that bracket could be wrong. We could be having wrong data here, so we'll also say else and give ourselves a bracket here. And we're going to set something here, a message box. And we're going to say invalid time and give it a semicolon. And here too, we will say text time dot text is equal to quote quote and txt time dot focus. We'll move it there. So if something goes wrong with the time, we'll be able to blank that out and send the user back up to the time area. So what's happening so far is we're kind of going to the right here and checking our data right here. Now we're going to be starting to look at the validity of the data. Is it reasonable or not? And we can basically say if int speed is greater than or equal to 0, I'm going to keep this in a positive mode, and int speed is less than or equal to 120, we're happy. And what we can do, int speed is greater than or equal to 0 and less than or equal to 120, we're going to be saying that's great, that's good. Else, ELSE, set up some brackets here, and message box dot show speed is out of range. And then we can take our speed and position the user. But if it's good, we can say if int time is greater than or equal to, let's go with 0 again. We might want to say 1. And int time is less than or equal to, let's say 12 hours. Keep that reasonable like that. We want to do something positive. Otherwise, another message box, MESSAGEBOX, time is out of range. And we want to take time and position our user to where we are. And we got an error right here, message box dot show time. What's wrong with message box dot show? IntelliSense is so helpful. Okay, so what you're seeing right now is you're looking at, we're going down to the right, and we have errors we're coming off to the left. So we're kind of creating an arrow. And what we can say right here, we can put a message box in here and say input data has passed all tests. So it's got to be an integer. It's got to be greater than 0, less than, it's got to be in that range. All those things are checked right here. This means we can do our processing. Proceed with processing. Proceed with processing. Proceed with processing. Now we can actually do our calculations here. And our calculations, basically, we're going to need another variable. We need something called distance. So we'll set that up on top here and say int distance. So we're going to say for. Let's set up a counter variable. Now we're going to say for x equals 1. That's our test, what we're setting it to. While x is less than int time. And we're going to increment x. X is equal to x plus 1. Close it off and set up our block. I got an equal sign here. This is where we'll do our test now. So we'll say int distance, or our calculation, is equal to int speed times x. Because we're really not multiplying times time, we're multiplying times the increments. The 1, 2, the 3, the 4, each hour we're actually going through the process. That gives us our distance. Now we can actually say to our LBX out dot items dot add, and we can say speed, a little space there, plus int speed plus time plus x plus distance plus int distance. Yeah, semicolon in there. I got a problem here. I don't have add. This should not be add items. Add quote. So there it is. Speed. Okay, just that. Now while that X got in there, it looks like it's fine now. Speed. Blah 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 blah. So forth. So on. So it's looking pretty good. So let's go ahead and run this thing. Save all. Start the program. Do our worst case testing on this thing. We'll put in garbage in both spots here. Look, use our tabs. Comes down, calculate, and bang, we got invalid speed. Okay, well, what's our speed going to be? Let's go with 50 and calculate again, and invalid time. Oh, okay, let's hit OK on this thing. The time should be 3. We'll hit calculate and bang. Well, we got a problem with our loop. The time is 1, 50, 2, set, so we're not getting the last one in there. We need to close this program. We didn't write the exit on here. And so we need to say our x equals less than or equal to time. Less equal to time. Time is going to be 3. Yeah, less than or, as long as less than or equal to time, we're going to be fine. That should be fine. I'll save all. This time we'll test it with outrageous data. We'll say minus 40 for our speed, and we'll say the time is going to be 600 hours. Go down and calculate, and we've got speed is out of range. Okay, so we'll set our speed at 50 again, and this time we'll say 600 time, and time is out of range, so it's giving us that information. So now we can go ahead and type in the time of maybe, let's say, 5 hours, and do a calculate, and bang, we get our 1, 2, 3, 4, and 5 are coming down. The speed is 50, 50, 100, 150. It's calculating correctly and going from there. So it's working just fine. I haven't programmed the clear button. I haven't done the exit button. We'd certainly want to do those things. But this kind of gives you the approach, and I'm going to go ahead and move this out. And just let you look at getting the input from the user piece here. Notice we're setting an arrow up and coming down this way. So we end up doing all this coding to prevent data we don't want to see in our program. When all we really want to do is this small little block right here. Typically that's what we do with our program. We'll write it and just do this piece. But when we're trying to guarantee that the data is correct coming in here, when we're looking at that flow chart, and we want the data to be proper, we need to go through some kind of routine where we're checking what the user might do to us. We're trying to thinking of what's all there. And that's where we need to look at this piece right here and check that data up front. Only after it's reasonable do you want to go ahead and process your data. And when it is reasonable, it'll be sitting right here, this spot where you want to do it, inside basically the pointing of an arrow almost. So this is where you put your code in. So I like to do my if statements, do my else's first, and then keep on trucking down until I've covered all my bases here, and then I can actually write my data. That's it. That's really what we're trying to do here. Did you see how that code was written? The if statement was written, and then the else was written. Another if statement was written, and then another else. All the responses to what might happen if something went wrong were written first. The actual processing code was only written after all the else's were complete. And the code kept indenting, so it formed a sort of arrow. I call this the validation arrow. Writing the code like this keeps all those braces in check. And it gets that negative stuff written and out of the way so you can go back and write code that actually processes the good data. It's amazing how much code needs to be written to protect your program from the user. It's the nature of the beast. And it's the reason we test our data. What you need to take out of this video is you need to protect your program from garbage input, alpha, when you expect numeric. You need to protect your program from negative data when you don't want it. You need to protect your data from unreasonable data, valid data that shouldn't be entered. Write your code with the validity arrow in mind. Get those else's complete before you write the processing code. Test, test, test. I'll see you next time. Thanks for watching. Don't forget to use the website for easy access to all my videos. If you get a chance, please subscribe. That way, you'll be notified when something new is available. We'll see you in the next video. Take care.